to see everybody here. It's nice to be able to get to see old friends and colleagues again.
And our residents as well. You know, we're
30 stories worth of fire hose seems like a lot, doesn't it?
Anybody wants to talk to Tom or about what that looks like, the fire stopping elements we're putting in buildings.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
Well, thank you very much for the opportunity to talk today. This is, I attended last year really talking about the document that's on the left-hand side of the screen there, which was a white paper written with very close liaison with insurers on the challenges set out by mass timber construction. Now, since then, the idea of that document was to really set the scene so that there were things to solve and so that people had a better understanding of what it takes to get a building insured these days. Because it is getting increasingly complicated, as I'm sure you've heard today. And actually, the last two talks have been the perfect background in which for me to deliver this talk today. But since then, people are rising to the challenge, and we are seeing some very good design solutions which are addressing many of the issues which were cited in that document. And on the 4th of May, this document, the Mass Timber Insurance Playbook, funded by Built by Nature and managed by the Association of Sustainable Building Products, was produced. So I'm one of the authors of this document, and to their credit, they've allowed it to go through really editorially unaltered. Now, why is that strange? It's because I sit in too many meetings about mass timber where actually you're not allowed to say that timber burns and you're not allowed to say it gets affected, because people get very upset about things like that. But the truth is, to really address the problems, you've got to identify what they are first. And between these two documents, they are well identified. And within this document, there is a framework given to assist people address them. So whatever you go forward with to your insurer is possibly more palatable. So what I've talked today about is really a crude introduction to insurance. This may sound very dull to you, but I sit in many meetings where the timber industry will say, actually, we need to educate insurers. But actually, it also works the other way around. And it's very good for designers and architects to understand the insurer perspective and how they actually do their sums to assess insurability. In fact, it's absolutely crucial. And I'm going to provide a few slides today which hopefully show you what the challenges are and how to put together a good case for a building at the end of the day. And it needs to start from day one of design. We'll have a look at consequences of material change and why local building regulations can exert such influence on this, potential design solutions, and then finally to introduce this document. I have some copies available if you like them, but it is also freely available from the internet also. Now, the key takeaway up front is that at the end of the day, insurers use a term called EML, estimated maximum loss, and you need to know what that is and why it's important. But the other thing is that the problems of insurability, they're not just about the materials used, they're about many other things. They're not just about fire, and they're not just about water. Many other things come into play. So I describe a little bit about this term EML, estimated maximum loss. If every building was insured as though it was going to burn down entirely, it would be very expensive, and I'm sure insurance provision would be very difficult and very punitively costly. So here we have a 17-story building. Now, let's assume we have a fire on one floor. Under insurance terms, the EML, we may assume we lose the fire floor to fire damage. We may crudely assume that 2 floors above might be damaged by smoke contamination. And we might assume that a floor below is subject to water damage from the firefighting activities. So in this case, the building might be insured on the basis of an EML of 4 in 17 floors. So there's no assumption that the whole building's going to burn down. But let's have a think on what merits do the building need to produce for you to be able to hang your hat on that and put your and stake your money on it. It's actually quite a lot goes into it. The internal fire spread has always been the domains of significant concrete floors. And now, of course, we're deviating from that. In this model, it infers that there is no external fire spread up the cladding system. And of course, that's the domain of non-combustible systems. And you can go on and on. But it's an awful lot goes into that simple assumption. So what happens when things come into play that deviate from this model and start to make things difficult? We've just heard from Ed an awful lot on green walls and the challenges that those present for external fire spread up the outside of buildings. Obviously, a route where fire can spread to every connected compartment to the external envelope of the building. It's worrisome, to say the least. Modular construction, or combustible modular construction. With every module lowered into place, there are cavities around it, voids, which have the potential to spread fire out of the domain of any suppression system, so heavily dependent on fire stopping, and obviously out of domain of the fire service as well, who are ill-equipped, understandably, to deal with fires in these hidden and dangerous locations. And also, we also need to consider the periods of insurance and construction, a key one where in many construction methods, the fire-resisting surfaces, both internally and externally, are the last surfaces to be applied to the building. So here we have a period of sort of heightened risk at the time of construction. Now, in putting together the white paper, I wanted to find some of the limits of insurer comfort to do with buildings. And this is what I'm saying. It's not just about what you build out of. It's about a great deal more than that. And actually, we ended up with a matrix of 26 insurability features that are really as few as you can get away with to consider whether it constitutes as a desirable building or not. So roughly split into six categories: occupation and use, pretty obviously; scale, that's a very, very large factor. The insurer appetite for large buildings versus a single occupancy can be very different because obviously that limits the ultimate scale of loss that can happen. Crucially, the fabric and the structure of the building. What materials are used? Where are they? Have they been intelligently applied? Are you using best athlete materials where they need to be to curtail the risks at that location? Then there are other risk factors. Now, obviously, given the audience, this might be unpopular to cite, but there are many things, certainly if you go back to maybe the Factory Mutual publication on looking at sustainability, they said any pursuit of sustainability inevitably increases risk. There's no free lunch here. And so whilst on the one side you can talk about the benefits of PV panels, wind turbines, green surfaces, they come with their own challenges, and these need to be addressed. Otherwise, it represents a big deviation from where we are. And I'd included with that things like atria, which an insurer, whilst produce lovely spaces, an insurer may view as a breakdown of internal compartmentation, if not correctly designed. And the two final criteria we have are the effort put in to mitigate fire, and increasingly the effort to put in to mitigate water perils. Now, for many insurers, the perils to do with water in large, tall, mass timber buildings represent a greater challenge than fire. The reason for that is that fires are rare events and obviously very costly when they happen, especially if they're not controlled properly. But escape of water events happen in their thousands every single day. Let's not forget, when you change from materials like bricks and mortar and concrete and steel, these are not only are they resistant to fire, they're also very resistant to water. And if you start to exchange those for materials which are more susceptible, such as timber, then that can change that. Now, in the domestic and residential environment, escape of water losses accounted for more than fire and security combined, coming on for £2 billion a year of insurance payouts on that. So I think you can see where the problem comes. And that's where we are building in quite resilient materials. Imagine now a future where we've changed to more susceptible materials and we're building at height, where any escape of water can be amplified down through the floors. And I think you can see that statistic is only going to go one way. So where does this leave us at the moment? Now, in the UK, the provision of insurance for mass timber is incredibly difficult, to the point where many projects proposed in timber go back to the drawing board and get redesigned in concrete and steel. And it's not ideal Insurers do not like turning down insurance propositions, but also they're not stupid either. And they do need things which have half a chance of working out for them and their investors also. So while this situation prevails, where there might be a lack of trust in a method, and then it leads to a lack of availability of insurance capacity. And under this situation, the insurance brokers need to work very hard. Remember, insurance isn't a right. Insurers can place their capacity in lots of different places to seek the best returns for the least risk. But at the moment, mass timber can be a very unattractive proposition. So that leaves the broker to really scrape around 5% here, 10% there from a range of insurers. And even then, they might be reinsuring back to the reinsurers, so less sticks to them still. It's a very difficult situation, and it ends up being costly. And as we said before, it can lead to people changing their design basic principles. If you compare that to when there's good trust and technical understanding, then there's a choice of insurers willing to provide 100% capacity, and that leads to healthy competition and low prices, and very much less reinsurance on this basis. So this is where we are at the moment. And really, so we've moved from a place of building out of very familiar materials with good pedigree and history and known resilience to some of the key challenges, to a point where we have very, very different materials indeed and requests placed on the insurer. And including all these lovely features, green walls, energy generating systems, and the like. So a lot has changed. But the principles of insurance can't change because they're pretty hard and fast. And they need to be totally agnostic about the benefits to the environment, because we're talking just about risk control and dealing what we're presented with, not about the necessary stuff to make the world, to sort of save the planet, if you like.
Book your tickets now for the 8th International Tall Building High-Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.
But let's have a look at what really hasn't changed. The building regulations in the UK haven't really responded to the challenge set. Now, that's a very big issue for us, because we know if it's in regulation, then generally it gets done. Actually, I think we've seen from Grenfell that even when it's required by regulation, often it doesn't get done. But that's a different story. So our regulations in the UK are about life safety. And if you want to put it very simply, that's about evacuation before collapse. After evacuation, there's very little interest in what happens to the building, but clearly there's a group of people, such as the owner of the building, the occupants of the building, and the insurer, who really want something to save afterwards and to put back to right. Not every building fire should end with the possibility of it being on the ground. And when you compare, say, to the United States, they have addressed this in the international building codes. So one of the key things which we'll highlight, obviously, is combustible voids. It's clearly a key area of concern. But in the International Building Code in the States, it will say if you have a combustible void, it will be filled with mineral fibre, or it will be lined with gypsum board, or it will be sprinkler protected. So in essence, by regulation, they've said that there's no such thing as combustible void, which makes everything an awful lot easier. And actually, when querying insurers about the palatability of different types of building using those 26 metrics, the American insurers were a lot more laid back, because they know if it's built in the States, it will be lined with gypsum board, there will be no bare wood surfaces, it will be sprinkler protected, so by and large they can treat it as a pretty ordinary building from that respect. But it's not the case for the UK. So the other thing that hasn't changed is all the other factors that contribute to insurability. How people expect buildings to perform in fire. That's a very interesting point. Our experience of how buildings perform in fire are built out of the use of materials which perform well in fire, but were the means to achieving the life safety objective. Their coincidental benefit to property protection has led us to believe that actually buildings survive fire, and actually they can be refurbished afterwards. But that is only coincidental, and as you move away from those materials, it won't necessarily be the case. And there's a likelihood that the future is that even compliant buildings will be of total destruction. But it doesn't have to be that way. But the measures to assure that are entirely voluntary. There's also an expectation of the availability and cost of insurance and lending, and this has been a shock. And it's probably fair to say that in the UK, for some types of structures, the insurer has become the de facto regulator for these types of buildings, which is not a position they want or they desire, but it's just the way it is in the face of of the regulation that we have. And of course, there's no sign of abatement of climate change. So we're heading into a very different environment. So the key forms of fire spread, which are really tackled in this document and really need to be addressed at the point of design if you want to impress those who have a higher interest in the building really performing at a property protection level. Obviously external fire spread and the use of good cladding to prevent that. Prevention of fire spread through the internal occupied spaces, and our building regulations do this very well. Now, nothing I'm saying here is a criticism of our building regulations in terms of their ability to preserve life. They do that very well, and the statistics for the UK are exemplary in comparison to other countries. But the internal fire spread is the story of really fire doors, ducts, dampers, and the like. But what we are seeing a lot more of at the moment is the introduction of voids. So here's in the bottom left-hand side there, really just as a fisherman's net could be thought of as a lot of holes sewn together with thread, really wall makeups now are becoming so lightweight. They are really a loose connection of voids connected with lightweight materials. And that makes things very problematic, and it makes designs immensely dependent on really CAD-level accuracy installation of fire stopping. And in there we see a massive challenge, particularly for the lighter weight construction methods such as light timber frame. Of course, we also need to consider fire spread between buildings also, because it's not uncommon for EMLs, estimated maximum losses for a building, to be assigned that are over 100% if there's a fear that fire may spread to involve other buildings also. And that can be immensely problematic as well. So what this mass timber playbook does is it basically conducts produces a framework to work within so that there is good communication between all involved parties so that all their requirements can feed into the design. And we were looking at the government requirements, the legislative ones, what the client wants. It's nice to deliver the building that they need to support their business continuity plan also, rather than just delivering lowest cost. And in association with that and completely aligned should be the requirements of the insurer. So the document sets the framework, and then using the REBA design stages, it looks to bring forward the resilient design strategy and address all of the issues using the confirmed insurer principles for the mitigation of fire, flood, escape of water, pest infestation, and rot, so that all these things get addressed at each of the REBA design stages and mitigated and pulled through the entire design as they go through. So that at the end of the day, you end up with a building where you have minimized many of the resilience issues that building out of combustible materials can introduce into the situation. This document is designed to be very simple, it's very accessible. It really centers around a number of guidance sheets, one pertinent to each of the REBA design stages. But there are also a number of supporting appendices which really describe the building insurability features, which I mentioned. They describe the insurer's essential principles for sort of fire and water and flood mitigation. Now, when we first showed it, there was no appendices C, which was example voluntary objectives and potential solutions, because when people read through it, they would sort of say, well, okay, what do you want us to do? Now, this isn't intended to be a prescriptive guide on what to do to get insurance. It leaves you all the freedoms to design buildings as you need to design buildings using all the tools that you have. But we have put in a few examples in the back, and I can describe a few of those as we go. So I won't go into these, but these will be very familiar to anyone in the UK of the REBA design stages, but it shows you where all the actions get introduced and what should be addressed at each one. And through these guidance sheets in this document, it tells you what you should be doing. So, simply put, the guide introduces sort of voluntary objectives which should align the business continuity planning of the client, insurer requirements, and knit those together with the other stakeholder interests to produce a very good remit to design to. It encourages broad and early engagement all the way through. There is a fear now that some buildings aren't getting even to the drawing board because they can't be assured of insurance at the end of it. Remember, these things start many years in advance, and that is clearly a challenge. People do need to understand the efforts you need to go to. Everything should have a pedigree back to EML, estimated maximum loss of that building, be it the installation of water detection and isolation devices, be it the use of non-combustible cladding and insulation. Everything should have a pedigree back to that to show that when it lands in front of the insurer, they can see that some effort has gone to address their side of what's important. Because at the moment, obviously, if a building can't get insurance, it probably doesn't get built at the moment. There are also other issues to address, which I'm sure will be well covered on repairability. And I'm sure parts of the solutions to this are probably to do with digital systems as well. So, what the guide inevitably leads you to, where there are risks, is really the potential for hybrid designs at the end of the day. Maybe the skinny use of concrete where you need concrete, but replacing large areas of the building with timber where you can. So obviously building on a concrete plinth where you have underground car parks is a good idea, or where you have flood risks. I think that goes without saying. But you can extend this thought to the use of a concrete core. Concrete core can add stability, but it can do so much more. One of the most difficult questions to ask of mass timber designers is actually, when there is a fire, what ultimately puts the fire out? It's a difficult question. Fire is, you're asking people to go into an environment which is potentially unstable. Smouldering combustion is very dogged. I've sat in many experiments now where after 9 hours, CLT will smoulder through and come out as flame the other side. And if that other side happens to be a combustible void, how does it get dealt with? You're inevitably going to end up relying on the fire service. Well, the fire service have no obligation to go and save your property once everyone is evacuated. So if you want their help, you need to design the building with them in mind. And at the moment, they're being left out of too many conversations on this. But a good starting point is to provide them confirmed structurally sound means of getting in and getting up, and then providing lots of other systems in place to support them so that they can be as effective as possible, because you are going to depend on them at the end of the day. But you can extend it still further. You know, having a concrete core is a fantastic place to route the critical services vertically. So now you've removed an awful lot of the combustible voids that you might otherwise have. Take it still further, it's a place you could put in the water-bearing rooms, the kitchens and bathrooms. So if you do have escape of water events, they go down in places where the materials are insensitive to that particular challenge. These are the things that are meaningful to insurers when buildings are presented to them. And I'd encourage people to actually have a think before just presenting them with an all-timber building. And we need to get away from the idea that buildings have to be all timber and any use of concrete is defeat. We need to just start talking about buildings, and buildings which are resilient and sustainable and use best athlete materials where they need to be, and on aggregate have the least lowest carbon footprint possible. So just to finish off, this document has been used successfully. I stole this from a previous person who's presenting, but Whitby Wood had a school built of CLT that they went to the market with and the insurers turned down. But then having used this guide, they understood that actually maybe around the science rooms and the laboratories, maybe you do need something slightly different. Maybe the toilets and bathrooms could be located somewhere better, so that the water, the potential for escape of water might be lesser. And by using this, they came out with a solution which was both insurable, predominantly wood, and a beautiful building. So I think that's all I had to say. Thank you very much for your time.
Book your tickets now for the 8th International Tall Building High-Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.